Chelate effect. What is the meaning of chelate effect? To know about this chelate effect, we all must know about a ligand. Again, one more time we have to revise it. What is the meaning of ligand? The one who is donating lone pair of electrons to the metal ion during formation of complex is called as ligand. That is L. That where we are indicating with L, right? While donating that ligand, if the ligand is donating the electrons to the metal with more centers, for example, if you are imagining a metal is like this here, if imagining four different ligands, if four different ligands are donating electrons like this, it is going to form Ml4 complex, right? This is one way that ligands can donate electrons to the metal. Now, what will happen in the case of chelate if same one if one molecule is going to have more donating sites, just like ligand is donating site, right? If one molecule is going to have more donating sites, if one molecule is going to have more donating sites, so here if you are taking this molecule, this is a molecule which is having two binding sites in this molecule, and this is a molecule which is having two binding sites. If this is forming a complex in which we can see here the ligand is two ligands. Two ligands are donating electrons to the metal at a time. In this case, it's not like that. The metals are donating electrons, sorry, the ligands are donating electrons to the metal. In this case, these two ligands are donating at a time. This type of thing is called as chelating. Chelating means it's one way. For example, if you are imagining like this, four sides, four sides from my hand, and it is holding this pen. So this is called chelating. Just giving this electrons to this metal is called just like giving electrons. But at a time giving together from only one source, that is going to form a chelate. So during chelation, what is very important to understand very clearly, during formation chelation, what is going to form? A cyclic ring is going to form. That is very important. So a chelating ligand is a bidentate. What is the meaning of bidentate? Having two spaces, two reactive centers to donate, or more bidentate, polydentate ligands, more binding sites, which is attached to the same central atom. Here, attached to the same central atom. I have taken as a general example here. I'll take it as a specific example in the coming slides. By two or more donor atoms, that is ligand, resulting in the formation of a complex having a strain free ring structure. Because obviously, if chelate is going to combine with metal ion, there will be a chance of forming. For example, now metal is there. I'm going to take ethylene diamine. Ethylene diamine. I'm going to take. So how it will look like? Ethylene diamine will look like here. So I'm going to take ethylene diamine here. Ethylene CH2 CH2. This is ethylene diamine molecule. What is going to happen? This ethylene diamine molecule, lone pairs are there, right? That lone pairs it will donate to the ligand. That time what will happen? There will be a formation of bond like this. So that time it will form a, we all can see here 1, 2, 3, 4, 5 member ring. That means like this a ring formed here. Obviously, it is going to be N, H2, whatever may be, right? In same way, here also NH2, NH2. So, this donation is called as chelation. Chelation means a ligand, there is a two sides are there in this particular molecule. If two or more sites are there, binding sites are there, then that will have a possibility to form, to donate the electrons to the metal ion at a time. That time it will form a cyclic ring like this. So due to formation of this particular cycle, the complex is going to be more stable, that we will discuss here. This formation is called as chelation. What is the meaning of chelation? A chelating ligand that is having two or more binding sites going to donate electrons to the metal. Donates the electrons to the metal at a time. During that donation, what happens? It will donate electrons here. During the donation, it will form a ring that is called a chelate. Right? Now, we have discussed about the definition of chelate. The complex having the ring structure is called chelate. Just now we have discussed, right? M, N, N, here. So here we can take it this NH, 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 NH here. We can take it as any oxalate. Any oxalate we can take it in this way. O, O. Same way M. So any ligand, any species which is having two ligand centers or more than that, it can form a ring that is called chelate. What happens if it is forming a chelate? That is a very important. What happens? It will increase stability. That we will discuss now. Actually, the chelate is also called by various names. That is called cyclic complex because it's cyclic in nature. That can be called as ring complex because it's a ring formation structure. It can be called as ring or cyclic. Why? Because they are having ring structure and cyclic structure, or also they will be called as chelate, chelate complex. So these are the different names of this particular chelate. Actually, the formation of chelate is also called as chelation or cyclization. Cyclization is not specifically to be here. This also can be called as cyclization because cyclization reactions are so many reactions. This chelation will fall one of the reaction in the cyclization type. So what? Why? Because this is forming a cyclic. And moving on to the topic called stable. Why this particular chelate is going to increase stability? Very important because just now we have discussed if two ligands are there in a complex, sorry, in a donating species, if two ligands are there in a donating species here, that time what happens? Due to this particular formation of ring structure, it will not be able to break easily. Obviously, what happens is the stability will increase. If a species forming species is can sustain for a long time, then that is called as stable. Why chelate is going to be stable? Because that's forming a ring structure that cannot break easily. If it cannot break easily, it will sustain for a long time and it is stable. That's the reason for the formation of a stable chelate here. So smaller dissociation of the chelated complex into its components in a particular solvent. Actually, chelate compounds will not undergo dissociation easily. If at all undergoing also, very little amount of chance are there. That's the reason they are going to form, they are going to name it as stable complexes. Chelating complexes are called as stable complexes. Now, let us discuss with the example. If a metal is there and around 6 ligands are there, right? 6 already take it here. 6 ligands are there. What it is going to form? Mn6, right? Mn6. Now, 6 binding sites are there which are donating electrons, right? That's what the meaning here, right? L, 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 L. So 6 sites are there. Even though 6 sites are there, this is not that stable as it is going to be stable by chelate. How? Imagine 2 ligands are there one species, 2 ligands are there in other species, 2 ligands are there in other species. These 3 are same molecules which are having 2 binding sites in one molecule. So here, if you are looking at here, right, 6 binding sites came from the 3 molecules. That means ethylene diamine we can take it here, and this type of molecule will form a chelate and it will be more stable. So let me take this example and I will explain in detail. If I am taking example cobalt, and imagine 6 ligand molecules that are monodentate ligand. What is the meaning of monodentate? Only one binding site. If there is only one binding site, it is ammonia is going to be called as monodentate ligand. Why? Because only one binding site is there. Monodentate ligand, dentate ligand. If more are binding sites are there, that will be called as bi, tri, depends on how many binding sites are there. If ammonia is having one binding site, then it is going to be called as monodentate ligand only. So this monodentate ligand can form complex in this way, and this is going to form a complex that is CO NH3 taken 6 plus 2. Now, same way, imagine the same cobalt is combining with ethylene diamine. Ethylene diamine. The same cobalt combining with ethylene diamine. Ethylene diamine. So, what is the specialty of ethylene diamine? Ethylene diamine is a ethylene diamine, and we'll call it as in. Ethylene diamine is a bidentate ligand. Why bidentate ligand? Ethylene ligand is why bidentate ligand? Because there are two binding sites. If there are two binding sites like this here, let's see what type of so here we can see chelates. Why? Because they are having more than one binding site. That is two binding sites. This is forming a chelate, and this process called chelation or cyclization. So here if you are seeing in general, very easy to understand, which is very which will undergo dissociation easily or in shorter time, this molecule. Compared to this one we are talking, this is also stable, this is also stable. But compared to both of them, right, this is forming a cyclic ring which is very stable compared to the acyclic one. And so this is more stable. Stability wise, if you are comparing cobalt EN, ethylene diamine, this will be more stable than this one. Only reason is it's forming a chelate. This is also called, this particular effect is called as chelate effect. This effect is called as chelate effect.